So f of x is equal to 18x squared plus 13, 18x squared plus 13 divided by 18x squared plus 13 divided by 9x squared plus 4. Divided by 9x squared plus 4. Now let's hear what they ask us to do. They say express f of x in the form a plus b over 9x squared plus 4. So they're asking us to do some polynomial division, some unit 1 stuff. So we're going to divide 18x squared by 9x squared plus 4. Doing the polynomial division, let's see what we're going to get. 18x squared plus 13. Now 9x squared into 18x squared goes into it 2. 2 times 9x squared, that is 18x squared. Then 2 times 4 is plus, 2 times 4 is plus 8. Then I do the subtraction. 18x squared minus 18x squared cancel each other. 13 minus 8 is 5. And so f of x can be written as the quotient of 2, so it's equal to 2 plus the remainder of 5 over 9x squared plus 4. So that's part 1. That's how we can rewrite f of x. Nice and easy, soft. That's how we can rewrite f of x. That's part 1. All right, nice. Now let's have a look at part 2. Part 2 says, given that f of x is symmetric, about the y-axis, evaluate the integral from -2 to 2 of f of x. Since f of x is symmetric, what they're telling us then is that the integral from -2 to 2 of f of x, I'm just going to write f for now. The integral from -2 to 2 of f, it's actually equal to 2 times the integral from 0 to 2 of f of x, because they're saying it's symmetric. All right, they're saying that the function is symmetric. All right, for example, an example of a symmetric function, x squared. The quadratic graph x squared, it's symmetric. All quadratic functions are symmetric. All right, we'll cut it in the line, x equals xt. So since it's symmetric, the area over here between 0 to 2 is the same as the area from -2 to 0. That's all they're saying, it's symmetric. All right, so 2 times the integral from 0 to 2 of f of x dx. All right, that's what we're going to have to evaluate. Okay, so it's going to be 2 times the integral of f of x is we're integrating from 0 to 2 of 2 plus 5 over 9x squared plus 4. That is f of x. That is what we're integrating. So we're integrating all of this. All right. Now, we can always separate it as this is always going to work out to be now equal to 2 times the integral from 0 to 2 of 2, just separating it, 2 times the integral from 0 to 2 of 2 plus 2 times the integral of 5 over 9x squared plus 4, right? 9x squared plus 4. That's what we have now. Now this look easier to integrate. Yeah, man, we separate it like this. Make it easy, man. So doing this integral, what we're going to get is when you integrate 2, you get 2x. So it's going to become 2 times 2x. And you're integrating from 0 to 2. Now this is a form, it almost looks like tan inverse, but it's not quite tan inverse. Remember, tan inverse tells us that we need it to be in the form of, we need to see our a, all right? And we need to see our x, right? So we need to put it in a better form. We know that a over a squared plus a over a squared plus x squared is tan inverse x over a. So look what I'm going to do. Instead of having 9x squared, I'm going to rewrite 9x squared as 3x all squared. I'm going to rewrite it as 3x all squared. Instead of having 4 right here, I'm going to rewrite 4 as 2 squared. So now I need a 2 in the numerator. I need a 2 in the numerator to get it to be tan inverse of x over a. I need a 2 in the numerator. But this is 5. No worries. 5, let me see, 5 divided by 2 is 2.5. So I'm going to factor out 2.5. All right, I'm going to factor out 2.5. Or maybe we can just switch this 5 on this 2. Why not? Yeah. Switch this 5 here to put it as 5 times the integral from 0 to 2 of 2 over 3x squared, 3x all squared rather. You write this a little bit better. Three x all squared plus 2 squared. All right, so all I did was interchange the 5 and the 2, and now we're good. Because then this part is now just tan inverse x over a. So this works out now to be, plugging in the 2, 2 times 2 is 4, 4 times 2 is 8. This works out to be 8 plus 5 times, this is now tan inverse, 5 times tan inverse x over a. In this case, x is 3x over 6. 2 squared is 4. Where I get 6 from? 3x over 2. Tan inverse x over a. All right, and this we're integrating from 0 to 2. Integrating from 0 to 2. So now all you have to do is plug that in, and you're going to get 8 plus, we don't need to plug in the 0 because tan of 0 is 0. So you need to just plug in x as 2. All right, and I think probably they're working in radians. So put a calculator in radians. 3 times 2 divided by 2. That's tan inverse of 3. And you multiply that by 5. All right, so it's 8 plus 6.245. 8 plus 6.245. And you work that out. And you get 6 plus 8 is 14. So that's the final answer. 14.245. All right, nice and easy, soft. Now, part C. Part C is asking us now, it says, let h be a function of x and show that the integral of h to the n ln h dh is equal to h to the n plus 1 times n plus 1 all squared into minus 1 plus n plus 1 ln h plus c. So that's heavy. All or it looks heavy at least. It says show that the integral of h to the n ln h dh, this is what we're integrating, and show that it should be equal to that. I'm going to call the integral I. I just like to call them I. Now clearly we're going to use by parts. Once I say logs and algebra, I'll use by parts. So of course we're going to call u our ln h. All right, u is ln h. Why is u ln h? Remember ILATE rule. ILATE tell us that logs come before algebra. ILATE, logs come before algebra. So u is ln h, and so du is, when you differentiate ln h, you get 1 over h, all right? And then that means dv is h to the n. So if dv is h to the n, when you integrate to get v, you're going to get v is equal to h to the n plus 1 divided by the new power of n plus 1. All right, so using by parts, I is going to now equal to, it's equal to u times v, u times v, u times v is going to be h to the n plus 1 over n plus 1, h to the n plus 1 over n plus 1 times ln h to the n plus 1 times ln h. That's uv minus the integral of v du. The integral of v du is going to be, v du is 1 over h times h to the n plus 1 over n plus 1, right, dh. That's what we're integrating. Now look at this now, look pre this, 1 over h, I can rewrite 1 over h as h to the minus 1. That is 1 over h. 1 over h is h to the minus 1. Now whenever the bases are the same, we can just add the powers. So what we're going to get is I works out to be equal to, I is going to be equal to h to the n plus 1 ln h over n plus 1 minus, I can factor out n plus 1 to factor out 1 over n plus 1. And since the bases are the same and I add the powers, I am just integrating h to the n plus 1 minus 1, that's just h to the n. So I'm integrating h to the n. Now carrying out this integral, what I'm going to get is h to the n plus 1, h to the n plus 1 over n plus 1 times ln h minus 1 over n plus 1 times, when I integrate h to the n plus 1, what I'm getting is add 1 to the power, so I get h to the n plus 1, then divide by the power. And then when you integrate, you always put plus your constant plus c. Nice. So that is what that works out to be. Now, from the question, as we can see, we have a h to the n plus 1 here. Now, n plus 1, they factored out h to the n plus 1. So finally, let's factor out, they want us to factor out h to the n plus 1. All right, so factor out h to the n plus 1, but n plus 1 times n plus 1 is n plus 1 all square. All right, so we factor out, that's it. So they factor out h to the n plus 1. So factoring out h to the n plus 1, what we're going to be left back with is we're factoring out h to the n plus 1 over n plus 1. This is it. Now look at this. You factor out h to the n plus 1 over n plus 1 all square. When you factor it out from this, you're going to be just left with minus 1. Plus, when you factor out this from this part, you're going to left back with ln h, but then times n plus 1. So you're left back with n plus 1 times ln h times ln h. You close that bracket, and then you put back your plus to your constant, your plus c. And you put your plus c. All right, so we're showing it. Nice and easy, and we use integration by parts. Nice and easy, soft. It says, hence, find the integral of sine square x cos x ln sine x. It says hence, meaning we need to use that. All right, so hence find. Remember, I call it I. So in this case, I'm going to call it, as you can see, it looks like they put n as 2. So I'm going to call it I2. And I2 is the integral of sine square x, sine square x, cos x, sine square x, cos x, times ln sine x dx. So looking back at the formula, the only thing that I noticed that they did was first is they substitute n as 2. They substitute n as 2. All right, they substituted n as 2. Then they substituted, what is h? H to the n. So they substitute h as sine x. So we need to identify what is h. They substituted h as sine x. All right. And that's it. They substituted h as sine x and they substituted n as 2. Yeah, man. So what we're going to get is this integral is equal to, according to the formula, it is h to the n plus 1. So it's going to be sine x to the n plus 1, but n is 2. So it's going to be sine to the n plus 1. 2 plus 1 is 3. So it's going to be sine cube x over, looking back at it, it's n plus 1 all square. So it's going to be 2 plus 1 all square, which is 9. 3 square, which is 9, times, it's going to be minus 1 plus n plus 1, which is 2 plus 1. 2 plus 1 is 3. ln h, which is ln h, and h is sine x. So it's plus 3 sine plus 3 ln sine x plus your constant. All right, nice and easy. n is 2, 2 plus 1 is 3, yeah, that's 9. 2 plus 1 is 3, just making sure all is well. So that is what this works out to be. And this takes care of question 2. Nice and easy, soft, capital T. Now we go to module 3.